Determine if the ODE is exact. If yes, find f of x comma y. All right, so here's the ODE we have. We have sine of x times y plus cosine of y, y prime. So right, the first thing we want to do is we want to identify Mars of x comma y, which is the piece without the y prime. We want to identify the Neptune of x comma y, which is the piece with the y prime. And right, so just to review here, going back, we're hoping this function f of x comma y exists, and the way we get down to the difference equation is we have Mars of x comma y plus Neptune of x comma y times y prime equals 0. To get from f to Mars, we took the partial derivative with respect to x. To get from f to Neptune, we took the partial derivative with respect to y. Now the next thing is if we go down further, so if I take partial Mars, partial y, well that should be the same. Let me just put in my partial y. If f exists, this should be the same as partial y, partial f, partial x. Then on the other side for n, if I do, let me just fill this in, this other side will be partial x, partial f, partial y. Didn't quite make the diamond I wanted, but if I go down here with partial x, then that would be partial Neptune, partial x. If this f function exists at the top, then we should have the mixed partials equal. If the mixed partials are not equal, then f of x comma y doesn't exist, and this equation is not exact. All right, so just that's a refresher, so let's go and check this. So we want to check that partial m, partial y, partial Mars, partial y equals partial Neptune, partial x. So let's go ahead and compute partial Mars, partial y. Well, that's partial y applied to sine of xy. All right, so that one, we get to do a chain rule. So the derivative of sine is cosine. I'm leaving a space in front here. And then we'll leave that. All right, then we take the derivative of the interior function. So I've got x times y, and I want to take the derivative with respect to y. That'll end up just being x in front, because the y turns into a 1. All right, so things are already looking pretty bad. Let's just go ahead and check. So now, next I want partial Neptune, partial x. All right, well that's partial x applied to the function cosine of y, and that's 0. So bad news, partial Mars, partial y does not equal partial Neptune, partial x. So the equation is not exact, the ODE is not exact. F of x comma y does not exist. So this assumption we made for this diamond shape, there's no top, so it really doesn't work out. And that's it, then we stop. Depending on the course you take and your lecturer, there is a way to sometimes take an equation that is not exact and multiply it by an integrating factor to make it exact. That's in the next, not the next video, but the next topic. But we're going to stop here for now because we solved the problem. We determined it's not exact. The answer was no, so we're not going to find f of x comma y.